What the one-to-one property says is as long as we have a base that's greater than 0 and not 1, if the bases are the same and they're equal to each other, that implies that the exponents are the same. Okay, so let's take a look at how this works in practice. We have 8 equals 2 to the 2x minus 1. Now, we cannot solve these using the tools we have. We can't like divide both sides by 2. We don't have a way to get the x out of the exponent. So what we're going to do instead is we're going to rewrite this 8 with a base of 2. So 8 is the same thing as 2 to the third power. And then I didn't do anything to this side. And now, since my bases are equal, I can just kind of ignore them. They don't really cancel out, but I can ignore them and say, look, if the bases are equal, that means the exponents have to be equal. So 3 equals 2x minus 1. And we can finish solving that for x. So x turns out to be 2. We're going to do the same thing in b. We're going to rewrite these so that they have the same base. Let's see, 27 is 3 to the third. I don't want to do anything with that negative x yet. 1/3, that's 3 to the negative 1. And then I can multiply those two exponents, so I get 3 to the x equals 3 to the third. And since the bases are the same, that means that the exponents have to be the same. So x equals 3. Now, the problem with the one-to-one property is it doesn't always work. Let me show you an example. Like if we have 5 equals 2 to the 2x, let's say, there's no way to rewrite 5 so that it has a base of 2. 2 to the what power gives you 5? I don't know. So one-to-one doesn't always work. It's not going to work for a problem like this. So we will need other tools eventually, and we'll get there very soon. All right, so we want to use the graph of 4 to the x to describe the transformation for all of these. So like we talked about with the graphs we saw on the previous page, all of our exponential graphs are going to go through the point 0, 1, and they're all going to look like this. Okay, the bigger the base, the steeper it goes up, but this is exponential growth. So we want to know what happens when we have a minus 2 with the x. Well, that's going to move the whole thing right 2. So instead of going through the point 0, 1, let's see if I can get a different color here. It's going to move over 2, and it'll go through the point 2, 1, and it'll look like that. All right, so then if we have a plus 3, that's going to move it up 3. So instead of going through 0, 1, it's going to go through this point, and everything will move up 3, and I really ran out of space there. And we need one more color. How about purple? And then this one, a negative and a minus 3. Well, the minus 3 is going to take it down 3. And the negative on the inside is going to reflect it. But it's going to reflect across the y-axis. So let's see. Reflecting across the y-axis will make it be exponential decay, and then we're going to drop it down 3, so it looks like this. Okay, so all of our basic transformations that we already know about our exponential graphs and any of our parent function graphs, they work for the exponential ones.